Hello and welcome to the video about complex numbers. To start the topic of complex numbers, what I would like to do is start off solving a quadratic equation. Now you know a quadratic equation as an equation. Of course it has an equal sign, so it's an equation with a variable raised to the second power. And what we have here is a basic quadratic equation. There's a couple of ways to solve this particular quadratic equation of x squared equals 1. You could subtract 1 from both sides of the equation and then factor. So you'd have minus 1, and you could say x squared minus 1 equals 0. Because most quadratic equations, it's appropriate to get it equal to 0 on one side and then attempt to factor. So this is a difference of squares. So this problem factors into x plus 1 times x minus 1, and then I set each factor separately equal to 0, and I get x is equal to negative 1 as one of my solutions, and x is equal to positive 1 as my second solution. And actually, that's not the way that I had in mind to factor it. To solve it. What I had in mind is leave it in this form, and then use the square root property. So I take the square root of the left side, and I take the square root of the right side. And as long as I take the square root of both sides, I'm using a property of equality that what I do to one side I must do to the other. But when you use the square root as a tool, you're required to remember that you have to put a plus or minus in front of one of the sides. So on the left side, the square root and the square cancel each other out. That's what we anticipated. That's why we did it. On the right side, if you evaluate the square root of 1, you get 1. But our two answers are plus or minus 1 are split up. X is equal to 1 and x is equal to negative 1. Now we shouldn't be surprised by that result because that's the same thing I got when I factored it. I presented that to you to reflect on something that you already know how to do. But let's look at a problem, a brand new problem, a quadratic equation. It's almost identical to the one we just solved, but we've got x squared equals to negative 1. Now if we go along the lines of what we just did, we would expect this to have two answers as well. And it turns out that if you have an equation that's quadratic, in other words degree 2, it should have two answers. But check out this problem. Now if I handle it like I did the first problem, I would add 1 to each side of this equation, and I have x squared plus 1 equals 0. Okay? Now here's the problem. If I go now to attempt to factor it, this is what we call a sum of squares because you're adding, and this is a perfect square, and this is a perfect square. Yet sums of squares don't factor. So this is not factorable. Okay? So then you think, well fine, let's use the square root property like we just did. I'm good with that. So x squared equals negative 1. I take the square root of the left hand side. I do plus or minus just like before, and the square root of the right hand side. Okay? But I have an answer here that's not real. Now why would I say such a thing? Well, you can't take the square root of a negative number. Remember, we've talked about this extensively when we were dealing with domain of a function, and you never want the values you plug into a square root to end up negative because you can't evaluate the square root of a negative number until now. What we're going to do is invent, basically. We won't be the first to invent it. Mathematicians have already done this thing, but the idea of something called a complex number, and that's based on the fact that the square root of negative 1 is I. Now, it's still not real. This is still not something you can graph. It's not a real number. It's a brand new thing called a complex number. So if you'll look to your right, over here, I have a list of what we call complex numbers. And I is equal to the square root of negative 1. So that is a definition now. Now again, this is not a real number. You still can't evaluate the square root of negative numbers unless you open this whole new type of number system, and it's called a complex number. Right now, we're just talking about what we call the imaginary unit I, so I'm going to write it over here that I'm saying the imaginary unit, and that's called I, and it's defined to be the square root of -1. Now what I want to do for you over here on the left, I'm going to erase where I attempt to solve the quadratic equation by adding the 1 to the other side so I can get that space back because I want to look at something. We're going to define I to be the square root of -1, so I would like to know what I squared is. Okay, well if I is the square root of -1, then I squared will be the square root of -1 squared. Now notice the square root and the square, remember those are inverses of each other, so my answer is -1. Okay, so here's what I want you to remember. Anytime you see I squared in some kind of calculation that you're working with, you automatically replace I squared with -1. Okay, and again, it's because when you square the square root of -1, the square root and the square cancel. Now let's simplify and figure out what we can get for I to the third, because if you ever see I to the third in a calculation, I want you to simplify it as much as you possibly can. Well, let's rewrite I to the third. I know you'll feel comfortable with this. I to the third can be written as I squared times I. Now why? Because remember, you add exponents when you multiply the bases. So this is a 2 plus a I to the first, which would give me I to the third back if I multiply them back together. Now let's substitute. I squared is -1, and I, we're going to leave it as I. -1 times I is -I. So if you're ever doing a calculation and you get I to the third as your result, it can be simplified further into -I. And then let's take a look at I to the fourth. Okay, now I to the fourth, I know you agree with this, can be written as I squared times I squared, right? Because 2 plus 2 gives you 4 back. Now I squared, we already know that's -1 times another -1. -1 times -1 is a +1. So anytime you see I to the fourth in the problem, you can replace it with +1. Now the most important one on this list, I want you to understand, is this one right here. I squared is equal to -1. You will see that frequently, so you need to have that logged in your memory that I squared is -1, and you'll make that replacement. So again, all we've done on this page is motivated the idea for something called an imaginary unit, and the square root of -1 is what we call an imaginary unit, and it's so these quadratic equations will actually have 2 solutions. Okay, all right, so let's keep going. Next we're going to define a complex number. All right, now a complex number is a number of the form a plus bi. So this a plus bi, as a matter of fact, this is what we call standard form for a complex number. So anytime your problem says write your answer in standard form, that is a plus bi. Now the a and the b are real numbers. So an example might be 2 plus 5i, where a is 2 and b is 5. Okay, those are always real numbers. They don't have to be nice looking real numbers either. It could be 1/3 plus the square root of 2i. That's also what we call a complex number, where a is 1/3 and your b is the square root of 2. Again, both of those are real numbers. A is called the imaginary part, okay? And actually, I have this backwards. Instead of fixing this page, forgive me, A is not called the imaginary part. Okay, I'm bleeping this out immediately. And BI is not called the real part. It's actually the other way around. A is called the real part, and BI is called the imaginary part. Okay, so then at A, again, in this part, 2 is the real part, and 5i is the imaginary part. Or on the next one, 1/3 is the real part, and the square root of 2i is the imaginary part. Okay, now, if we go on, it says if b is 0, okay, so let's see what that would look like. If I wrote a number down where b is 0, that might be 3 plus 0i. Well, 0i is just 0, right? That would just give me 3. Notice it says that's a real number. And all real numbers actually can be written in complex number form. So 3 plus 0i is just 3. That's a real number. On the other hand, if a were to equal to 0, like 0 minus 5i, this is called purely imaginary. You could rewrite that as just negative 5i, and that's what we call a purely imaginary number there. Okay? But here's what we know. All real numbers are also complex numbers, because any real number like 14, you could write as 14 plus 0i, right? So all real numbers are complex numbers. But on the other hand, a complex number is not a real number, because this number right here, for example, 0 minus 5i, is imaginary. If there's an I in the result at all, it's called imaginary or complex. Okay? And these imaginary numbers or complex numbers cannot be graphed in a regular XY axis, which is only dealing with real numbers. So keep that in mind. The next thing, imaginary numbers are equal, and this ought to make perfect sense to you. A plus bi is the same number as c plus di if a and c are the same number, and also if b and d are the same number. And then you know that they're equal to each other. So let's work with some of these complex numbers, shall we? So it says simplify the complex number. We've got the square root of negative 81. Now we already know that's not a real number, right? Because we cannot take the square root of a negative number until we have this brand new number system called complex numbers, and now it's allowed. So here's the way I want you to think about this. The square root of negative 81 can be broken down into the square root of negative 1 times the square root of 81. Right? If I multiply those two back together, that would give me the square root of negative 81. Now the reason I did this is so you could realize that the square root of negative 1 is I, and then the square root of 81 is 9. Okay? Now the next thing I want you to realize is we always write the I in the back when we're multiplying. So this is equivalent to 9i, or if we wanted that in standard form, it would be 0 plus 9i. And either of these is appropriate. Okay? 9i or 0 plus 9i. So let's do this again. Let's work with the square root of negative 100. Again, you can think about this as the square root of negative 1 times the square root of 100. Okay, well the square root of negative 1 is I, the square root of 100 is 10, and you could write that as 10i, or 0 plus 10i. And again, either of those is appropriate. Okay, now I know you're thinking, does she want me to show that much work? You don't have to. As a matter of fact, anytime you see a negative under a square root, you automatically know that's an I value. So you've got I times the square root of 48 that you must deal with. Now here's the next issue. 48 is not a perfect square, right? But we can break it down. So the rule is, if you have a perfect square, not a perfect square, but there's a perfect square that'll divide into that. And you know what I mean by perfect squares. If we made a list of them, if I put them over here on the left here in brown, 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square because 3 times 3 is 9. 16 is a perfect square. 25 is a perfect square. 36. 7 times 7 is 49. You could make a list if you needed to. Well, I'm looking for the biggest number on this list that divides into 48. And the biggest number that divides into 48 is actually 16. So I can write 48 as the square root of 16 times the square root of 3. Follow me? Because 16 times 3 is 48. Now the square root of 16 is 4. So this part I can write as 4i square root of 3. Now the square root of 3 won't break down anymore, so that is your final result. Or you could write it as 0 plus 4i square root of 3. Now you might be thinking, how'd she know to put the 4 in front and then the I and then the square root of 3? So here's the rule. All that's multiplied together. We always put the I behind the real number part. So, or behind the non-radical part. So notice the I went behind the 9 and the I went behind the 10 and the I is going behind the 4. But any square roots that you have, It's usually conventions of books to put that at the end of the list of multiplied factors. Okay, so 4i square root of 3. And the reason they put the square root at the end is so you don't accidentally take that bar too far across and like write it over the I or over the 4. If you put it at the end, it doesn't matter how far you draw that bar, you're not going to accidentally put it over the 4 or the I. So now we know how to simplify complex numbers, and basically what it comes down to is if you have the square root of a negative number, that's an I. Okay, you just pull out the square root of the -1 and call it I. So now what we'd like to be able to do is operations with these things. We'd like to be able to add, subtract, multiply, divide. And I give you the definition for addition, but before I show you what that is, what I would like to do is just work a problem and show you how easy this is. Okay, now if you were to do this problem, intuition would tell you that you probably are going to work with like terms, and that's exactly what's going to happen here. If I take a -2 and I add that to 3, that's the real part. -2 plus 3 is 1. And then I'm going to take the 5i and add it to I, which is like terms, and that's going to give me a positive, so I'll put plus 6i. And this is what we call standard form for a complex number. Okay, so it's as simple as that. I'm doing -2 plus 3 is 1, and 5i plus I is 6i. And if you go back and look at the definition for addition, that's really all we're doing. If we're taking a plus bi, it says we add the a part plus the c part first. So that's what's going on here. And then we take the bi part and add it to the di part, which will give me b plus d with the I on the outside. Okay, now again, what I say is like terms. Okay, that's not what we're used to thinking about like terms, but really the I is not a variable. It represents the square root of -1, but it still works to think that way. So for subtraction, you got to be very careful. Why? Because you're subtracting this entire complex number, so that minus needs to distribute. So that's exactly what I'm going to do. I'm going to write 3 minus 2i. That's the original complex number we're given. And then this negative of a negative is going to be plus 2, and this negative times this plus 4i will be minus 4i. Just like when you're dealing with polynomials and you have to distribute a negative, this is the same thing. Now I'm going to add the real parts together. The 3 and the 2 are the real part of your complex number, and -2i plus a -4i is -6i, and that is in standard form. Okay, let's try this again. Now, notice your first complex number only has an imaginary part. It's like 0 plus 5i. But it's not required that you write that down. Now the negative must distribute, so it's -1 plus 7i. And now you just add like you would a polynomial with like terms. 5i plus 7i is 12i minus 1. But now that shouldn't be how you write your final answer, because that's not in standard form. Standard form, the real part comes first, -1, and the imaginary part, which is 12i, comes next. So what I'm looking for is -1 plus 12i. You write the real part first, which is -1, and the imaginary part second.